Okay, so we're going to start off by graphing the parent function of a quadratic. We'll go ahead, I'm going to do this one in purple. The parent function of a quadratic, if I plug in 0, it'd be 0. And then after that, we know we go 1, 1, 2, 4, and then 3, 9. And this is that pattern we've been doing for a while now. Okay, so this is what our parent quadratic looks like. And we've already been doing this as well, so this really isn't new to you. Okay, so then if we were to graph the parent function of the radical, which is what we're working on right now, this is the inverse, right? So if we graph this, now keep in mind we're doing the function, so we're only doing part of this graph, which means we have to actually restrict this part. So the domain of the quadratic that is going to work with my parent square root function will go from 0 to infinity. And we've been covering this as well, so this isn't new to you. After that, we're talking about we just kind of reflect all our values, right? Well, this one's going to be here. This is 1, 1. If I flip those around, it's still 1, 1. This one is 2, 4. So instead, it's going to be 4, 2. That one is 3, 9. So instead, it's going to be 9, 3. Okay, so this is our inverse. Oh, that's a horrible curve that I drew, sorry. Our domain is going to be from 0 less than x less than to infinity, and our range is going to be 0 less than y less than infinity. And what you'll notice is these x and y's always change, so your domain and range always change as well. You can't see it as much in this because all your numbers are basically the same. But you'll get to see it as we work down below. So now we're going to talk about from that parent function, which I want to go ahead and I'm going to graph again. It's going to be right here, it's going to be right here, and then it's going to be 4, 2. Okay, so those will be the 4 main points we're going to worry about graphing. And I'm just going to go ahead and I'm going to take a second and I'm going to graph each parent function because we're going to move those. Okay, so hopefully by now you paused it and you've graphed each one of the parent functions on those graphs. So all that is so far I've graphed the parent function square root of x. So now I'm interested in graphing the transformed one. Whenever you look at whatever's happening, for example, this is a 2. It's on the outside. If it's on the outside, that means it's going to multiply your y values. So for example, this y value right here is 1. If I multiply it by 2, this is where it'd be. The next y value is at 2. If I multiply that by 2, it would go to 4. And then the last value is 3. If I multiply that, it would go to 6. Okay? And that's what that outside value is going to do. You may be recalling this, okay? Outsiders impact your y's. It's doing 2 times it, so. So once again, if I were to just plug in 0 to this, it would be 2 times the square root of 0, which would give me 0, which matches up with where my first one is. If I plugged in 1, it would be 2 times the square root of 1, which is going to give me 2, which you'll notice that's where we have our point. Then it would be 2 times the square root of 4, which equals 2 times 2, which is 4, which once again, you'll notice that's where that point is as well. Last one would be 2 square root of 9, which would be 6. And you'll notice that matches up. So I don't have to create a table to do a transformation if I just use the skills that I already know. Okay, so let's go on to number 2. Number 2 is a little different. This time you'll notice the 1/2 is on the inside. Insiders lie. According to this, it's saying to take x and multiply it by 1/2. Instead, we're going to take our x values and we're going to multiply them by 2 because that's how it's lying to us. It's like saying to divide by 2, we're going to multiply by 2. So this first x value right here is 1. 1 times 2 is 2. This next x value is 4. 4 times 2 is 8. Okay, and then after that, this x value right here is 0. 0 times 2 is 0. My last point would be off the graph, so I didn't do that one. So then let's go ahead and plug it in. If I did the first one, it would be 1/2 times 0, which would be 0, which matches our point. The next one would be 1/2 times 2, which would equal 1. And you'll notice we got a point at 2, 1. The next one would be 1/2 of 8, which would be the square root of 4, which is 2. You'll notice we have a point at 8, 2. And then, of course, our last point would have been, the x value would have been 9. and that would have multiplied by 2, which would have given us 18. That still would have been at the value of 3, though, because you would have had 1/2 times what? 18, which is the square root of 9, which equals 3, okay? So once again, I just used the tricks to transformations instead of worrying about a table. Okay, so looking at this next one, this is telling us, remember insiders lie? So this is telling us to go right 3, and this is telling us to go down 1. So that means every point is going to have to go, I'm going to start at 0, 0, right 3, 1, 2, 3, and down 1. Right 3 and down 1. Right 3 and down 1. And then the last one would go off the grid. Okay? So then if I were to plug in their values just to check to see how it worked, I got 3 minus 3 minus 1. Square root of 0 minus 1 is -1. So if you'll notice, 1, 2, 3, I have a point at 3, -1. So you'll see how I didn't need to create the table. If I plug in 4, 4 minus 3 would be 1. Square root of 1 is 1. 1 minus 1 is 0, which you'll notice is right there. 7 minus 3 is 4. Square root of 4 is 2. 2 minus 1 is 1. 12 minus 3 is 9. Square root of 9 is 3. 3 minus 1 is 2. And you'll notice those are matching up. Hold on a second. How'd that last one go? 12 minus 3 is 9. The square root of 3. Oh, yeah, I didn't even get to that one. That makes sense. I stopped right here. We didn't even, and you'll notice as we went out, that would have been up there. Okay. That 12, 2 didn't even make it on our grid. Okay, so we got one more of these. This one's going to be, my negative is on the outside, so it's telling you to flip over x-axis. And then this is telling you to move it up 4. So this might be the one that would be, I guess, the most troubling. If I'm going to take, for example, my first point, 0, 0, and I'm going to flip it over the x-axis, well, it's not going to flip anywhere, correct? But then after that, it's going to move up 4, so I got to go 1, 2, 3, 4. So that's where that point's going to go. This point, my next point, 1, 1, would flip down to here, but then it would go 1, 2, 3, 4. Okay? My next point would flip down to here, but then it would go 1, 2, 3. It would actually land in the same spot, wouldn't it? And this one would flip all the way down here to a -3, but then it would end up counting up to there. So the first thing that's going to happen is it's going to flip over the x-axis, but then the entire graph is going to slide up as well. So let's plug in 0. If I have negative square root of 0 plus 4, I'm going to end up with 4. If I have negative square root of 1 plus 4, then I've got -1 plus 4, which gives me 3. Negative, my next one would be 4. Square root of 4 plus 4. And notice, these always, you pick the ones that you can actually get a pretty square root to. Square root of 4 is 2, so -2 plus 4 gives me 2. And then I got -9 plus 4. That would give me -3 plus 4, which is 1. Okay? So let's see, is that it? Did we get everything? Nope, got a few more. Oh yeah, that was just the first little bit in it. Okay, so at this point, if you want to, you can pause and you can practice, do some of the practice on your classwork, which would involve your graphing. So that would be the first part here, if you'd like to pause at this point. And then you can come back when you're ready. So now we're going to talk about solving radicals. Your steps are going to be, you're always going to isolate the square root first. Then after that, we're going to square root both sides. And when you're squaring, you may get answers that actually are not answers, okay? And we'll go through that in just a minute. They're called extraneous solutions, which are actually not solutions at all. So starting by taking a look at number 1. We're going to start off by subtracting 8. So I got x plus 1. The square root of x plus 1 equals -6. Okay? Then step 2 tells you to square both sides. Well, if I square this side and I square this side, then I get x plus 1 equals, and this will be 36. And then I get x, subtract the 1, and I get 35. Okay? However, 35 is what I would consider to be an extraneous solution. And here is why. Plug it back in, and you get 8 plus 35 plus 1, and this is supposed to equal 2. 8 plus something is not going to equal 2. And here was your first heads up right here. When I was going to take the square root of x plus 1, there's no way that was going to spit out a negative number. In other words, the square root of anything is never going to be any type of negative number. It's not. So that would be an example of your extraneous solution. It's not going to happen, but because we squared it, it allowed us to come up with an answer that really does not exist. Okay? Then we also, number 2, first step would be to subtract 1. So I get 2 to the radical 3x plus 4 equals 14. Next step would be divide by 2, because remember, the first thing you want to do is isolate your radical. Okay? This is a square root equals a positive number, so this is a possible scenario. So now at this point, we would square both sides. That would allow me to get 3x plus 4 equals 49. Now we've got subtract the 4, and I've got 45. Divide by 3, and I have 15. Okay, so if we went back and plugged this in to check it, we would have 3 times 15 plus 4 plus 1, and this should all equal 15. So let's see, 3 times 15 is 40, 45, plus 4 is 49. Square root of 49 is 7. 2 times 7 is 14, plus 1 equals 15. So you can see how that one did work. And x equals 15 actually is our solution. So once again, your goal is first, you want to get your radical by itself. After that, you can square it. In this case, my radical is by itself, so I'm going to square both sides. When I square the side with my radical, it'll come out of my radical. 1 times 1 is 1. And then after that, it's just solving. Subtract the 11, and I get negative 10. Notice this is okay because my radical is already gone. And then I do divided by 5, and I get negative 2. If I plug it back in, 5 times negative 2 plus 11 is supposed to equal 1. This is going to be negative 10 plus 11 equals 1, and that will be 1 equals 1. Number 4, you'll notice you have a radical on both sides, but other than that, there's nothing else. So we would just square both sides. So we get x squared plus 7x equals 13x minus 9. Now to solve this one, you're talking about it being a quadratic, so we need to get it all to one side, and then we're going to have to factor or use the quadratic formula. So if I subtract 13, I'll get negative 6x, and then add the 9. Okay, so from this point, I'm interested in those numbers, right? It would be 9 on top, negative 6 on the bottom, two numbers that multiply to give you 9 and combine to give you 6. So you got negative 3, right? And if we wrote this out, completing the square, some of you may have already done this in your head and you know what it is. Well, if we put these together, we end up with x, we got x minus 3. Over here we would pull out, I wrote my things a little prematurely there. Let me erase that. Okay, so then over here we'd pull out our negative 3, leaving me with x minus 3. Okay, so now I got x minus 3, x minus 3. So that means our solution is x equals 3 because they're both the same. If you set them equal to 0 and solve, that would be your solution. At this point, if you want to practice solving on your classwork, now would be a good time to pause and then come back. Okay, the last thing we're going to cover is operations with radicals, okay? And this is just like combining like terms. So when you're adding or subtracting radicals, what you always need to make sure of is the radical is the same. If I have 2 of the square roots of 3 and 1 of the square roots of 3, then I can add them. So this would give me 3 square root of 3. However, if I had 2 of the square root of 3 plus 2 of the square root of 2, you'll notice these two are not like. They're not the same. That's the like term you're looking for. The number that is underneath the radical must be the same for you to be able to combine them. This one, there would be no combining. It would be done just like it is. So this one over here, I'm going to have to simplify a little bit. Square root of 8 is 2 times 2 times 2. So these come out, and we're left with this inside. Once again, my radicals are the same, so I can combine 2 and 7 to get 9, and then my square root of 2 goes unchanged. Just like if you were doing 2a plus 7a. These two have to be the same. The radicals have to be the same, and if so, then you can add them. Multiplying is a whole different thing. You just straight up multiply them. So this means 2 times 3, 5 times 8, which would give me 6. And then let's see, 5 times 8, well that would be 5 times 2 times 2 times 2, right? Those will come out. So I've got 12 with a 10 left on the inside of my radical, okay? 7 times 21 is the same thing as 7 times 21. Well, 21 is 7 times 3, which means a 7 will come out and the 3 has to stay inside, okay? Those I think you'll probably do okay. We've kind of covered those a little bit just in the work we've been doing. This is just FOILing. So I got 4 times 4 is 24. Then I got 4 times negative radical 2. Then I got radical 2 times 6. So I got plus 6 radical 2. Notice these two things are the same, so I will be able to combine them. And then I've got positive and a negative, square root of 2 times the square root of 2. Well, square root of 2 times the square root of 2 is 2, and it's going to be minus. 24 minus 2 gives me 22. These combined will give me positive 2 square root of 2. And that's as far as you can take it because this 22 does not have a radical. Conjugates, we've worked on these as well. These are the exact same except they have different signs, which means their middle term is going to go away. 5 times 5 is 25. We'll just work it out so you can see it happen. Negative 5 square root of 3. Positive 5 square root of 3. Notice what happens to these two. And then square root of 3 times negative square root of 3 will be 3, right? Because I got negative 3 times 3. 25 minus 3 gives me 22, and that would be it because our middle term disappears. Dividing radicals. This can also be written just like this. 50 divided by 2. Well, 50 divided by 2 is 25. Square root of 25 is 5. Next we have 27 divided by 4. So let's think about this. That would be the same thing as 27 divided by the radical of 4. Well, I know the radical of 4 is 2. 27 is 3 times 3 times 3, which means I've got 3 square root of 3 all over 2. Next one would be 10 divided by 5 is 2, and then I've got 32 divided by 4, which would give me 2 square root of 8. Square root of 8 is 2 times 2 times 2, so I've got 4 square root of 2. Last one is rationalize denominator. We've done this like literally a couple times and that's it. To rationalize denominator, you're going to write the conjugate. So if this is 4 plus square root of 5, we're going to do 4 minus the square root of 5. And we have to do it top and bottom. In other words, we're actually multiplying by 1 because these two things are the exact same thing. And so 4 minus the square root of 5 divided by 4 minus the square root of 5 is actually 1. So we're not changing the value of this. That being said, when I multiply out the bottom, you'll notice I'll get 16. And then I'll get, my middle term is going to cancel out. I'm going to go ahead and write it, but you're going to get to where you don't write this anymore because you know it's going to cancel out. And then my last one is going to be negative 5. So I end up with 16 minus 5, which is 11 on the bottom. Okay? On the top, I'm going to take my 2 and I'm going to distribute it, which is going to give me 8 minus 2 square root of 5. So same thing. This time it's 3 minus square root of 2, so I'm going to multiply by its conjugate, which will be same numbers, opposite sign. What I do on top, I got to do on bottom, right? So same deal. 3 times 3 is 9. I'm going to go ahead and multiply them, but they're going to disappear. 3 square root of 2, and then negative 3 square root of 2. So notice they keep disappearing. And then I got negative square root of 2 times square root of 2 is 2. 9 minus 2 is 7. On top, I get 8 times 3, which is 24. 8 times square root of 2 is 8 times the square root of 2. And that would be it. There's nothing else you can do with it. They will not simplify any further. You have some classwork practice that goes with each one of these, so hope this helps. If not, come in and see me.